Hello and welcome. In this session, we're going to explore an essential part of submersible pump: maintenance and repair, motor winding. Submersible pump winding is a core skill for technicians working in industrial settings. This process directly affects pump performance, efficiency, and longevity. Let's dive in. Part 1. What is submersible pump winding? Submersible pumps are widely used in industries like water treatment, construction, mining, and oil and gas. The motor, which is sealed and submerged in fluid, must work flawlessly underwater. Winding is the process of wrapping insulated, copper or aluminum wire into the stator slots of the motor. This creates electromagnetic coils, which produce a rotating magnetic field when electricity passes through. This magnetic field interacts with the rotor, spinning it and powering the pump impeller. The quality of winding affects everything from motor, torque to thermal stability and electrical efficiency. In short, if the winding is poor, the motor fails, even if everything else is perfect. Part 2. Materials and tools used. To do proper winding, you'll need the right materials and tools. Let's start with materials. Enameled copper wire, preferred for high conductivity and thermal performance. In some cases, aluminum is used for cost savings. Insulation materials, slot liners, base paper, and wedges are used to protect the windings. Epoxy resin or varnish, applied after winding to seal and waterproof the coils. Lead wires, for making connections to the power source. Thermal sensors, often embedded to monitor heat buildup in industrial motors. Tools include manual or motorized winding machines, insulation resistance tester, megger, multimeter, baking oven for curing resin, wire cutters, strippers, and measuring tools. Part 3. Steps in the winding process. Now let's walk through the step-by-step winding process for an industrial submersible pump motor. 1. Disassembly and cleaning. Start by carefully opening the motor housing. Remove the old winding and clean the stator core using compressed air or solvent. Inspect for core damage or overheating signs. 2. Measuring and selecting wire. Check the manufacturer's winding diagram or replicate the original winding. Choose the correct wire gauge and number of turns per coil. Measure the slot size to ensure proper fit. 3. Winding the coils. Use a winding machine or manual setup to wrap coils tightly and evenly. Place each coil into its respective stator slot, using slot liners for insulation. Keep phase groups separated with insulation paper to avoid short circuits. 4. Connecting coil ends. Join the coil ends based on the motor's wiring. Configuration, star or delta, for 3-phase motors. Solder or crimp the connections and insulate with heat shrink tubing or varnish tape. 5. Electrical testing. Test resistance with a multimeter. Each coil should show similar ohmic values. Use a megger to test insulation resistance. For most motors, it should exceed 1 MeOhm at 500 VDC. 6. Varnishing and curing. Dip the wound stator in epoxy or insulating varnish to seal windings from moisture. Bake the stator at 130-150 degrees for 2 to 4 hours, depending on varnish specs. 7. Final assembly. Reassemble the motor, checking alignment, bearings, and seals. Perform one last continuity and insulation test before powering up. Part 4. Common mistakes in troubleshooting. Now let's talk about mistakes to avoid and how to troubleshoot issues. Common mistakes: using the wrong wire gauge or number of turns, loose winding or poor tension, skipping insulation layers or poor varnishing, incorrect phase sequence or wrong connection type. Troubleshooting tips: if the motor hums but doesn't rotate, check for shorted windings or incorrect connections. If it trips breakers, check insulation resistance and current draw. If it overheats, verify wire size, varnish curing, and check for rotor misalignment. Part 5. Safety tips and best practices. Safety is non-negotiable. When working with pump windings, always disconnect power before servicing. Use PPE, especially insulated gloves and safety glasses. Make sure your work area is dry and clean. Follow lockout, tagout procedures in industrial environments. Also, keep records of resistance readings and configurations. It helps in future maintenance and troubleshooting. Thanks for joining this session on industrial submersible pump winding. Whether you're rewinding motors in the field or in a shop, attention to detail and understanding the process can prevent costly breakdowns and extend pump life. Stay safe and keep learning.